So JNV Nizamabad, if the screen is clear to you and I'm audible to you, firstly let me clear with this. So make sure the screen is visible to you and I'm audible to you. Okay. Then we will start the lecture. And we will wait for 1 or 2 minutes more for the others to be joined. Got it? So if the screen is visible to you and I'm audible to you, please answer it no? In the chat box. So we will wait 1 more minute, then we will start. Okay. Till now, what we have done with the Zener diode, uh, photodiode, LED, which is light emitting diode, and also solar cell we have also discussed, okay, in the previous lecture. So these are the uses of these semiconductor devices, and these are called the special semiconductor device. Okay. We have a various use of it. We will see, we will use LED. We have used LED in a very large amount. Okay. Even if your mobile or your screen on which you are attending this lecture, it is also a LED. You know? So LED is the light emitting diode. It emits the light whenever the possible current is passing through it. So it emits the light. Okay. And how it is possible for that light emitting diode to emit that light? So it is because of the, sorry. Hello Pratibha, how are you? So is the screen is visible to you and I'm audible to you, Pratibha? Please answer it. Then we will move further in the lecture. Okay, got it. So as I'm discussing with JNV Nizamabad, till now we have done with the special PN junction diode. In the previous session, we have seen it, the various application of Zener diode, of special PN junction diode. It is a Zener diode that we have discussed, and photodiode, light emitting diode, and also the solar cell we have also discussed. So there are various industrial, commercial, and domestic use of these devices. Okay. The LED is used worldwide, okay, na, in the domestic, commercial, and industrial level. And if you talk about the photodiode, it is also industrially utilized. Photodiode is nothing but the a sensor. You can use it as a sensor because whenever the light falls on it, okay, it absorbs the light and regulate the circuit. So this can be used as a alarm system, or you can use this device to save energy. Okay. So in your household, if you have put a light on and keep it on, then it absorbing the power, and so it is a loss for you. But if you somehow you connect it with the photodiode, so, and in the reverse biasing situation, what will happen when the photodiode captures the light whenever the sunrise, it automatically cut off the circuit and the light will be switched off. So it will also use in that way, you know. So these are the few basic applications of these special PN junction diodes. Although they are not limited, the uses of these diodes are not limited. They are we are using them worldwide at the industrial level, commercial level, or domestic level. Okay. So today we are with the lecture number 9 of semiconductor. I hope this will be the last lecture or the second last lecture, I mostly. So hi Namita, how are you? So in today's session, what we are going to learn. So let me just. So today, what we are going to do, we are going to discuss the digital communication and logic gates. So it is a very important topic from the point of view of your examination, upcoming examination like JEE Main, and in boards. It is also a very common topic to be asked and a very important topic from this all. And this logic gate is a different topic from your entire physics. It separate from you from the physics. Okay, this logic gate. So there is a different type of mathematics that we are going to use in building the logic gates. Okay, so it is a very small topic yet very important. Okay, so we just start the lecture. First of all, we will deal with what is signals. Okay, now what a signal is. We usually use this term कि whenever we are talking someone via phone or mobile phone. So whenever there is no network in your phone, you will see that there is no signal. Signal is not coming, or you are not a proper range. Your voice is breaking. Like for me also, one of the student has told me that sir, your voice is breaking. That is why the signal is not strong. Now, what is this signal? What we are talking it about all the time? Like, okay, there is a song also based on this signal. So we would not focus on that. We will focus on that problem that whenever we are talking with someone relative to us on mobile phone and we are not in a proper range of network, then we usually say that there is no signal in my phone. What does that mean? You are facing a network issue. No? Now, what is networking? There is a transfer of information. Okay. You are talking to someone, you are sending your message, voice notes you are talking. Okay. That voice note will be converted into digital signals in your mobile phone. And then again, it will convert it into electromagnetic wave. These electromagnetic wave are transferred to the another mobile phone, the another person that you are talking with. Okay. If there is a miscommunication, if there is a misalignment in this structure, so he or she will not be able to capture that signal or that wave. Okay, so that is why we would usually say that there is no signal or you are not in the range. Okay, so signal means it is a way to communicate. Okay, it is a basic unit of the communication system that we are having today. Okay, so moving next in the signal. So a signal is nothing but an electromagnetic wave, okay, that we use to transfer. This is very important. Carrying data. So whenever you are talking with someone on your mobile phone, okay. So what they usually say that the signal is not coming, which means the data that you are forwarding with. And what is that data? Your voice. Your voice you are forwarding with that person and it is not receivable for that person. Okay. So who is carrying that voice? Who is carrying that data? That data is carried out by signals. A signal is nothing but the electromagnetic current or the electromagnetic wave. Okay. So a signal is an electrical or electromagnetic current that is used for carrying data from one device or network to another. Okay. So what is happening when you are communicating with someone? What is happening? You are transferring your data in terms of your voice to someone else, है ना? And he is receiving that data, the same data that you are transferring. Like in this video call also, whatever data I am transferring to you, whatever it is in the form of PPT or my voice or my video, that is the signal that is carried out by the signal that is going to receive on your mobile phone or tablet or from whatever device you are connected with me. Yeah? So that is signal. Okay. So you have to take one note of it, that a signal is nothing but an electromagnetic current or wave which carrying data, okay, na, from one device to another device. It is like a pigeon, a kabutar that we used to transfer in the ancient days from one place, sending messages from one place to another place. है ना? So now you will remember signal means the kabutar that you have. Okay? Which we use to transfer the data from one place to another, transfer the signal, transfer the message. Okay. So with the next statement, you can easily know that signals are used to carry information from one device to another device. Okay. And this information is in the form of electromagnetic current. Like I have told you, whenever you are talking, or like I am talking with you, so my voice is converted into this electromagnetic wave by some means, and that is carry forward to your devices, and they are doing just replica. They are just doing opposite of that. They are disconverting this from electromagnetic wave to voice. Okay. So a signal used to carry information from one device to another. Now, so there are two types of signal we have. First, we have the analog signal, and another signal we have the digital signal. Now, analog signal we will discuss first. What is an analog system? You must have heard about the watches type. Analog watch है या digital watch है ना? So that is also because our our watch is also transferring the signal. Na? It is also transferring the information to us in terms of time management. Like from the watch you can convey, oh this is evening at 5 p.m. 5 ठीक है ना? नहीं, today at 15:21 we are taking this lecture. Okay. So analog signal is nothing but a continuous signal. Okay. That contains a time varying quantity, because it means it is a signal but it is time varying, which means it depends on the time, okay, for which it is transferred. Okay. And it is a continuous signal, so there is no break in receiving that signal. Got it? Now it transmits the data in the form of wave, because wave is a continuous body like this. Got it? Now if you will see that if this is a wave and this is time varying or time dependent wave, so there are more possibility that the signal or that the information you are capturing in this, whatever the information you have infused in this, is more chances to be distorted, because it is time varying. So as time varies, the signal quality, the strength of the signal will decrease. That is why this has a more chance to be distorted. And one of the quality of it's like it is continuous. So that is why also to maintain the signal in the proper form is also very difficult, because it is a continuous way. So you have to supply the power to carry out this signal continuously. Okay. There is also one of the limitation, and that is why also it is distort. And the more chances to be distort. Okay. So more prone to be distortion. Got it? Now, it is represented by a sine wave, and you are also aware about the sine wave. Sine wave is represented by this. It starts from 0, it at 0 again, and this is 1. Okay? In terms of numerical value, I'm talking about. It is not 1, it is pi by 2, and this is pi. And this maximum one is maximum of the sine is 1. Okay? Because sine function has a range of -1 to -1 to +1. Got it? And one thing more, it has a time period of 2 pi. Because after 2 pi, you will see after this time, the wave start repeating itself. Got it? So this is the analog signal. Got it? In the uh, operation theater, the pulse meter that is representing the pulse of of a patient, it's also an analog signal. You will see there is a continuous wave which is traveling through that. You have seen through it. It is traveling through like this. Huh? So it is a continuous wave there. And in that case, we need a continuous data. Okay? Because in the case of this medical supplementary, we cannot say that, okay, we got the heart rate for now, and let me just take the heart rate after 10 minutes. No, that is not possible, because, and that is not the way to doing it. Because if you are taking the measurements of this like the heartbeat after 10 minutes, and within that 10 minutes, if the patient has some difficulty to breathe or difficulty to take any of the pills and whatever the surgery you are doing, okay, and in that, within that 10 minutes some mishappening was there, so how do you know? After 10 minutes you will say, oh, the patient is dead now, I'm not responsible for that. No, you are the responsible one, because you have to analyze the signal, analyze the heartbeat in a continuous manner. Per second you have to see that. So that is why in that case we need a continuous signal. Got it? So example, human voice. Our voice is also continuous. You have also seen it, the pressure wave. We have a pressure wave. So what we are going, how the sound travels. Sound is a longitudinal wave, as you will know. Okay. And it is a kind of pressure wave also. So the signal or the voice that you are receiving at your ear will be a pressure difference, because your ears are made to receive or analyze the pressure difference. There are two types of difference in the wave a wave can make, the longitudinal wave. It first is the density difference, varying of density, and second one is the pressure difference. Okay. So the voice you are carry forwarding to your friend, or I am carry forwarding it to you, it is a kind of pressure difference. Okay, and density difference too. But your ears are made in such a way, it is built or constructed in such way that it can only read the pressure difference, not the density difference. Okay, so that is why you are able to uh, receive my voice or listen to my voice. Okay. Now, if I talk about the digital signal, so a digital signal is a discrete, which means it is not continuous, discontinuous information. Okay. So this is what we have to learn. So it is a discrete wave that carries information in binary form. And what is binary form? It is 0 and 1. 0 means low voltage, or 1 means high voltage. or you can see 0 means off or 1 means on. Okay. So you have to remember this. Analog signal is a continuous signal and digital signal is the discrete signal or discrete wave. Okay. And it carries the information in form of binary wave. Got it? Now it transmits the data in binary form, that is a form of bits. Okay. You whenever you recharge your mobile phone with the data, like data khatm ho jata hai, to we recharge na our phone with 1 GB, 2 GB, 2 GB per day you are receiving with your plan. So what is this GB? What does this mean? 1 GB means 1 GB. It is made of, let me tell you, this 1 GB. 1 GB means, and GB itself means is the gigabytes. Gigabytes. Now, with this 1 GB is made of 100 and 1024 of MB. This MB is nothing but megabyte. This 1 MB is equals to 1024 KB. KB is nothing but kilobyte. Okay. And this 1 KB is made up of 8 bit. And these bit are nothing but the blocks. Okay. And this block has two variation, either it can have 0 or 1. And this 0 or 1 is nothing but the information. Information. And this information is termed as what? Data. What do you understand by data? Data is the set of information, na? So this bit is nothing but the a discrete form of data. Okay. So whatever, which means if you are recharging your phone with 1 GB, you are allowed to take 1024 megabytes of the data. Okay. Like my video you are receiving, and by the end of this lecture your phone will say to you that you have consumed 200 MB of your daily data. Okay. Which means the information that your phone has received from this lecture is of 200 megabyte. Okay. And this information is the form of the voice, the video, the PPT, and the software that you are using. Okay. Because this video that I am recording now, it is converted in electromagnetic wave. This electromagnetic wave are transferred to the station, not the railway station, the tower station, the main tower station, from network station, from where all the signals are connected. These signals are carried to the satellite, which is in our zone. It also send the signal to the receiver end, that is in our area, in your area, from my end. Okay. So what does happen? That will receive that information, it carry forward to your devices, then your devices again convert it into from electromagnetic wave to the voice, the audio, the video, and the data. Okay. That is how this process is going on. So whatever you are transferring, whatever you are receiving a data. So this 1 GB is nothing but a data. It means 1 GB. Okay. Now, so the bits, I think you have clear. Bits is nothing but a block of 0 or 1. Either it carries 0 or 1. Okay. And 0 or 1 is nothing but the information. Okay. It is the binary form. Binary form only have two signals. This is 0 or 1. Okay. Now, next point. So these are the digital signals. You will see. Just a second. So these are the digital signals. Zero means low voltage or off, and one means high voltage or high potential, or means on. Okay. Now it has a less tendency to be distorted because this is not continuous. Okay. And only two signals are there, 0 and 1. So very less tendency to be distorted. Okay. And it is represented by this square wave, which means from here to here the signal is 1, here to here the signal is 0, again 1, again 0, again 1, again then 0. Okay. So it has less tendency to distort because it is not continuous. Okay. So you only have to give power to that point, only the specific reason in which you need high voltage, either it will be 0, so you don't need to supply the power then. Okay. So less power consuming also, less power consumption. Okay. Now you can see here this signal are used for transmission in a computer, because your computer or your any electronic device will work on this digital signal. Okay. This binary form of digital signal. Now if you will see the example of this bulb is keep itself on and off, which means if we set the bulb as an electronic device and this on and off are the signal, digital signal. So on means 1 and off means 0. So when it is off, the signal transmitted is 0, and when it is on, the signal transmitted is 1. Okay. And in binary form, when it is on 0, when it is on, then 1 will be transferred, and when it is off, 0 will be transferred. Okay. Now the topic that we are seeking here is logic gates. Okay. Now what is a logic gate? From its name you will understand that a gate that has a logic, you know? Okay. So logic gate is nothing but a digital circuit that we have. Okay. And if it is a digital circuit, it must have the binary output, binary input, input and output. Okay. Because it is a form of digital circuit that follows a logical relationship between input and output voltages. Okay. So we have a digital circuit in which we build a logical connection or logical relation between input and output. Okay. Which means you give an input and the output you will receive is based on that logical relationship that you have applied in that. Okay. You will more understand as we going further in this lecture. So these logic gates are the building block of any digital electronics, okay, which process the digital signal in a specific manner. Okay. Got it? Like recently Diwali has come, okay, and in our house we generally use these LED bulbs, the lots of LED bulbs, okay, na, for the decoration purpose. But one common thing that you will see, there is a remote in that, and there is a button in that remote. If you press it, the connection between the lights on and off will change. Either they will on itself, keep remains on, or they will on and off type thing, है ना? Or they will change the color. So from there is a circuit now. from these all LEDs are connected with. So that remote and that button is connecting with this logical signal. So whenever you press the button, another logic is keep on working. Another types of digital signal transfer to that LEDs, and that is conveyed to us. Okay, got it? So you can understand it in that way. No, it is used in calculator, digital watch, computer, robots, industrial control system, and telecommunication, which means a lots of field it will cover. So without logic gate, you can imagine a computer will work or digital watches will work. Okay, got it. So it is very important to learn this topic in a very efficient manner and in a very focused way, because you will see in practical life whenever you're seeking a job and all that, these things are very important to you, and that will also help you to cracking that interview and all that. These are the very first thing to be asked if you would become an electronic engineer and you are going to a interview. So this will be the first thing that the interview will ask you: what is a logic gate? Okay. So if you will see the uses of it, it is used in calculators, digital watches, and one of the most important is telecommunication. Without telecommunication, can you imagine a single day from tomorrow or from today? No. Digital communication is a part of our life now, and it is the building blocks. The logic gates are the building block of it. Okay. And also the industrial control system it will use. Okay. We will utilize that logic gates in industrial control system also. Okay. In robots also, whenever you have to lift up this limb or you have to uh, open your this fist and you have to make the fist for the robot. So these are the logics now. So that is also the one of the most important application of it. Okay. So there are 5 common logic gates that we use. First is this not, you can say anything, but these three are the fundamental and these are the derived. Okay. So this not, and or, these three gates are the fundamental gate. Fundamental gates, and these two are the derived one. Derived gate. Okay. Which means these are the basic building blocks, and these other two, this is NAND or NOR, these two gates are derived from these are the combination of these gates. So we will discuss gates one by one. Okay. Now, so logic gates mein, what does the logic means? This means follows a logical relationship between input and output, and this gate is the controls the flow of the information. Okay. And then what is the truth table is also important concept of it. Truth table is the all the possible input that a logical level combination can give to you. Okay. With respect to the with respective output, which means you give an input, this is the input, and this is output, and there is a logical relation between them. So whenever the input you transfer to it, whatever be the possible output that can be possible will be tell by this truth table. Okay. So truth table shows that all the possible input logic level combination with their respective output logic level. Okay. So whatever input you will give according to the gate you are using, that logical relation that you are using, the possible output will be tell by this truth table. Okay. So truth table also help us to understand the behavior of the logic gates. Okay, how this particular logic gate will behave, that is also be understandable by this truth table. Okay. Now the types of logic gate. First is the NOT gate we are going to learn. NOT means na, है ना? Which means it is rejecting something. Not acceptable. Okay. It is rejecting. So it has one input, only one input is there, and results in one output. Okay. So this is the logical symbol of it. It has a triangle followed by a circle. Okay. This A is the input and this Y is the output. Okay. So suppose we have input and output in the form of binary, and binary has only two inputs, 0 and 1. And if this gate is working, this is the logical relation. So what will be the output? That we are going to discuss now. Okay. This is input and this is output. And this is the NOT gate in between input and output. So suppose you have provided an input 0. What does a NOT gate do? NOT is rejecting it, which means it gives you output of 1. Okay. It just reverse the input. And if you give it 1, it will give you 0. Okay. So there are only two possibilities for this. Either you give it 0, so it will give you 1, or you will give it 1, so it will give you 0. It just it just make the opposite decision. That is why it is a NOT gate. Okay. It does not accept the input that you are giving to it. Okay. And this is a very important to learn the logical symbol of it. Got it? So produce a 1 output if the input be 0. I have told you. So this is the truth table of it. A is the input. I have told you. Y is 0, the output will be 1. And if the input is 1, then output will be 0. Got it? How you can make this mechanically? So suppose there is a switch here and there is another switch, and this is connected to some load, and this is the battery that you are using. Okay. So there is a circuit breaker we are using here. Okay. So whenever, and there is a switch here, and here is the circuit breaker. So whenever you put that circuit on, okay, so what will happen? The circuit breaker will break the circuit and you will have no output in this situation. And if you open this, the circuit breaker will join this and there will be the output of it. Or one of the example that we have used for this exam in the relation, when we are using a rectifier, है ना? So in rectifier, in full wave rectifier, what is it is doing? In both the situation, it is transferring the current. Okay. Or in the half wave rectifier, it is only accepting the possible input when you switch down the circuit. Okay. And it is not giving you any output when the circuit is not on. Okay. Now, So it is also known as inverter because it inverting the signal that you are giving, inverting the input that you are giving to it. Now the OR gate. So OR gate has two, at least two input and one output. This is the logical relation. These lines are curved, not the sharp. These lines are curved. So this is the logical symbol of what? Of OR gate. And these are A and B, both are the inputs. And Y is the output. So how does this gate work? This will, if you giving it 0, let me make the truth table of it. Truth table. So here we have A, B as input and Y as output. So suppose I have given A as 0 and B as 1. So what will be the output for OR gate? So if any of the output has 1, it will give you a high output. It will give you 1. If any of the output is 1, it will give you 1. But if the output is 0, in both the input you have 0 value, then you will receive a 0 input, 0 output. And when both the circuit and both the switch is on, then you will have a on situation, or you will have the output of it. Okay, 1. So only in that case, in this particular case, when no circuit is on, no circuit is switched on, or no input is given, only 0 input is given, then you will have a 0 output. But in another case, you will have output. Okay. It is like here you have a switch, again you have a switch, and these all are connected to a load, and this is connected to a battery. Okay. So when the current is flown, now this situation leads us to 0 and 0 because both the circuit is open. Okay. So there will be no current in the circuit. Now if I switched on one of the circuit, if I close one of the circuit, the current will flow through it, and it will not depend on this circuit is open or not. So this is the case when one output you have provided and 0 is the input, one input and 0 is the input, then you will have a output. Okay. Similarly, if you closed both the switches, then also you will have the current. Okay. Only the case when both the switches are off or having 0 input, then you will have a 0 output. Okay. So I hope you are clear with this OR gate. It is clear to you, every one of you. Please let me know if you have any doubt. Okay. So output is Y is 1 when either input A or B is both are 1. Okay. I have discussed with the table. There is nothing more to discuss with it. Okay. So if the A and B 0 0 is there, then only you will have a output 0 1. But in other case, you will have output 1. Okay. So if any of the input is high, the output is high. The 1 is called as high and 0 is called as low. Okay. Now the AND gate we are to. So AND gate is also having two input and one output. And if you will see the symbol of it, it is like this. One of the surface is flat and another is the curved one. Don't forget the signal, the logical symbol of this. Okay. This surface is also curved. This is also curved, and it is a kind of arrow type of thing. Right? Sharp arrow. And what is the signal of NOT gate? So it is a triangle with dot. ठीक है. Yeah, JNV, you have raised a hand. Any kind of query you have? Any kind of doubt you have? You can just write it in the chat box if you have any problem. Okay. If you not understood what I am talking about, okay, you can write this thing in the chat box. Now, the AND gate. It also a two input, one output gate. This is the logic symbol of it. How is this working? Let me draw the truth table of it. Okay. So this is A and B are the input, Y is the output. So if A is a 0, B is also 0, then output you will have 0. If A is 0, B is 1, which means the input at B is high, then also you will have 0. If this is 1, this is 0, then also you will have 0. Only the case when both the input are high, then only you will receive a high signal in the output. Got it? So this is the truth table of it. Now only situation when this AND gate will work, only in this case. Okay? This is like the set that you have learned in your mathematics. There is an AND relation, na? And it is being like this, the intersection part. Okay? So A intersection B takes that thing which is common in both and rejects all the things. Okay? So this, if you will see, this 0 0, that is why it is 0. But in this case, 1 and 1, both the things are same, both the input are same. That is why it is carrying 1 as output. But in these two situations, the input is not same. So that is why it is not having any kind of output. Okay? Got it? Now, this is the truth table. If A is 0, B is 0, then Y is 0. A is 0, B is 1, Y is also 0. A is 1, B is 0, then also Y is 0. Only the situation when both the input are high, we will have a 1. Okay. Now, this NAND gate. This NAND gate is nothing but NOT plus AND. So it is a combination of NOT gate plus AND gate. Okay. Now, in this also we have two input or one output. But the reverse in this case will be like whatever the input you will have from the AND gate, the NOT gate will reverse it or invert it. Okay. So this is the symbol of AND gate, but this dot, with this dot it will become NAND because this dot representing the NOT gate. Okay. Now if you will draw the truth table of it, A, B, and Y. So if A is 0, B is also 0. So whatever input you will have, if there is only AND gate, if there is only AND gate, whatever input you will have 0. But this is not only the AND gate is here, it is also a NOT gate present here. So NOT will invert that input, which means it will give you 1. Or we will tell you according to this. This is Y dash and then you have Y. This Y dash is the output for AND. Output for AND. And this is output of NAND. Got it? So 0 0 for AND gate, it will be 0. For 0 and 1, 0. For 1 and 0, it will also 0. For 1 and 1 only, in this case, it will have. But in NAND gate, the relation, logical relation will complete by this NOT gate. So 0, which means it inverted 1. It also inverted 1. This 0 is also inverted into 1. But in this case, this 1 is inverted to 0. Okay, it is the AND gate followed by the NOT gate. I hope you are clear with the truth table also. 0 0 you will also have 1 0 1 1 1 0 1 and 1 1. In only in this situation, when both the input are high, you will have a low input. Okay. Now NOR gate, I hope you are understand this by its name. है ना? It is not plus OR, which means it is a OR gate followed by NOT. So two or more input. Yeah, this is the logical symbol of it. Okay. This is the symbol of OR gate. Only if you put the arrow in front of that, it will become a NOR gate. Okay. Now, if you draw the truth table of it, the truth table. So again, we are going to do that in that situation, y dash and y. This is for OR and followed by NOT. So it will become NOR. Now in OR gate, if it is 0, it will also be 0. If the both the input are 0, then you will have 0. If either one of the input is 1, you will have 1 in OR gate. है ना? But here is not only OR gate, there is a NOT gate also. So it will invert the input, which means 0 become 1, 1 becomes 0. Okay, so this is the truth table of this NOR gate. Okay, got it? So I hope you are clear with this. Rest, we have two special gate also we have. So we will discuss in the next lecture, and the next lecture will be the final lecture of this chapter. Okay. If you have any kind of doubt in this lecture, you can just ask. Otherwise, the lecture is being over. Thank you so much for being attentive in this lecture. Thank you so much. Okay. Take care. Bye bye. Yeah, Jane, we have any. If you have any doubt, you are raising your hand, na?